So one of the big challenges with IoT is where you deploy. A lot of times in IoT, you don't have the luxury of deploying in nice data center environments or enterprise offices. You have to deploy outside in agricultural settings. You have to deploy in big industrial facilities next to machines. So there's a lot of challenges here. One of the key challenges we need to deal with is electromagnetic interference. So here's how this can happen. As you may know, if you have a conductor and you expose it to a changing magnetic field, that changing magnetic field can induce a current through the wire. And the opposite can happen too. If you have a wire, that can create a changing magnetic field as well. So the problem with this is if you have a wire and it's transmitting information and it's exposed to changing electromagnetic interference, that can generate noise in the wire, make it harder for you to read the signal. So it turns out this happens a lot. And it's something we have to deal with, especially in IoT settings, where you have these devices everywhere. So the problem here is if you have a conductor and the conductor moves through a magnetic field or the magnetic field is changing, there's an electric current that's induced. This is referred to as electromagnetic induction. And if you've taken physics before, you might have heard of the right-hand rule, where if you have a wire and you have kind of a current going through it, you point your thumb in the direction of the current, it induces a magnetic field that kind of wraps around the wire. And if the current goes in the opposite direction, the magnetic field is kind of polarized in the opposite direction. So EMI comes from a lot of sources. It comes from other wires, because there's other wires generating these magnetic fields. It can come from the background environment, cosmic rays. Unfortunately, when you kind of deploy these things in the wild, EMI comes from all over the place. And so it's something we need to protect against. Because what it does is it induces current fluctuations in your conductors, whether you're running a wire, whether you're deploying a device. And the problem this creates is called crosstalk. Because if you have other devices or even random noise in your environment, it makes your device less stable because it changes the information inside your device and changes the information going over wires. So what can we do about this? It's a big problem. You know, we're deploying these devices in the field, we like to protect them. Well, I'm going to tell you a trick, something that you can do to protect your devices. And the way it works is we're going to take your IoT device or your wire and we're going to wrap it in a conductor. Because what happens is if you have an electromagnetic field and you wrap your device in a conductor, the field will induce a current in that outer conductor, which will create the opposite effect of the electromagnetic field because it will kind of suck the electrons on one side of it, which will cancel it out. So you can see this more clearly through a little animation I'll have here. So what we have here is we have a kind of square chunk of conductor. And then we have an electromagnetic field that goes through this conductor. And you can see what happens is on the positive side of the field, it kind of pulls all the electrons to that side. But what that does is that creates a negative field on that side of the conductor, which cancels out the positive field on that side. And the same thing happens on the other side of the conductor. So if you've ever heard of a Faraday cage, that's what's going on here. If you kind of take a conductor and you put it on the outside of your device, it's like magic. It just kind of prevents the electromagnetic field from getting inside your device. And this is an amazing trick which is used all over the place in all sorts of devices and microwave ovens and things like that. So the main idea here is we can actually shield from noise by wrapping your device or your wire in some sort of sheath. And there's different kinds of sheathing we can use. So there's braided shielding, there's also foil shielding, and there's different trade-offs here. So if you kind of look at the shield effectiveness for different kinds of electromagnetic interference, you can see different kinds of shields perform differently with different powers of interference, different frequencies, and so on. And this is important to keep in mind because when you're building a device, you got to think about what you want to protect it from. Do you want to protect from high frequency, low frequency, powerful effects, or less powerful interference, and so on. So in general, what we're going to do is we're going to take our conductor or a device and we're going to encapsulate it in an additional conductive layer called a shield. And what the shield is going to do is it's going to absorb the electromagnetic interference, or it's going to reflect it, or it's going to conduct it to ground. It's going to protect what's inside of it from that electromagnetic field. And there's a lot of different kinds of shields. two very common types are known as metallic foil and braid shields. And in general, foil is cheaper, but it's worse for flex. The nice thing about braided shield is, it's kind of got a whole bunch of braids that kind of fit together, and so if you want to bend it, they can just kind of bend and flex. But if you have foil, the metal is actually bending back and forth, and that can weaken over time. So if you have something that flexes a lot, you want braiding. Another trade-off is that braiding is good for low frequency, whereas foil is good for high frequencies. So if you're deploying something like Ethernet or some sort of really high bandwidth communication, you want to use foil because you're dealing with really high frequencies, whereas braiding works better for low frequencies. So foil is widely used for commodity Ethernet. Now, you can actually get the best of both worlds by taking your device and encapsulating it in foil and braiding, and this gives the best shielding. So what I've done here is I've given you an overview of how you can shield your wires and your devices from EMI, and there's different ways to do it, and by knowing some of the trade-offs here, you can make better decisions about how to build your devices and how to protect them from EMI.